Hello and welcome to the first set of difficult questions that I have for P3. We will start solving and see where this goes. The first question says the parametric equations of a curve are this and that. Show that dy over dx equals to minus 2 sine square half theta. Now half theta is something that doesn't pop up a lot. Let's see what we can do about this. So this becomes 0 minus the differential of cos theta is minus sine theta. Okay, so dx over d theta is sine theta. dy over d theta is minus sine theta minus 1 over 4 minus sine 2 theta into 2. So I get minus sine theta plus sine 2 theta over 2. So dy over dx is then dy over d theta divided by dx over d theta over sine theta. So minus sine theta over sine theta plus sine 2 theta over 2 sine theta. I divided the denominator into both. I get minus 1 plus 2 sine theta. So I get minus 1 plus cos theta. Okay, now let's try to figure out how to do this. Now remember this identity where you used to do cos 2 theta equals to 1 minus 2 sine squared theta. We did this in the lectures that this angle is always half of that. So what if I told you that cos theta can be written as minus 2 sine square half theta. So that means cos theta would be, if I shuffle this around, 1 minus cos theta and sine square. Let's make cos theta the subject, right? I think I just need to make cos theta as the subject. So I can just substitute here, in fact. And that should solve the problem. Okay, that's what I wanted to prove. So this comes up from the double angle identity. Remember that half theta is not an identity on its own, but a double angle identity. Moving on to question number 5 from February, March 22, version is 3.2. Okay, the angles alpha and beta. In fact, that's not a difficult question. I think I'll find another difficult question for you. That's the next question that I have. This is February, March. This is the same paper as before. And this is February, March 22. I'm not sure why the previous part had just one question, had just one part. Yeah, that's just one part. Okay. Moving on to this question. It says find the quotient and remainder when this is divided by 4x squared plus 1. So whenever you have this kind of question, you have to do long division. That's the only way of finding both the quotient and the remainder simultaneously. So you multiply by 2x first to get 8x cubed, and you get a complementary 2x here. Then you subtract, so you get 0. This gets cancelled out, so I'm just not going to write that. 4x squared plus 0x plus 7. Okay, there's a subtraction sign here and there. Then you multiply by 1, you get 4x squared plus 1. You invert the signs, again cancel out, and you get 6. Okay, so quotient is 2x plus 1 and remainder is 6. Let's check if you have the right answers. I don't want to move on to the next part without first figuring out if I have the answers correct. Okay, yes, the answers are correct. Let's move on to the second part of this. It says, hence, find the exact value of this. Now, this is an integration question. Remember that I can't integrate this directly. I will have to use the previous part. My quotient came out as 2x plus 1, and remainder was 6. Now, remember that in your O levels, you do this long division where you, let's say, divide 4 by, let's say 17 by 4, let's not do 17, let's say 21 by 4, you do 4 5 20, and then you have 1 as the remainder. You can write this as 5 whole 1 over 4. So I'm going to do something similar here. I'm going to write 2x plus 1 whole and then the remainder over the divisor. Okay, and I'm going to put a plus sign in the middle. So this expression that I just divided can be written like that. Okay, and then I can integrate simply 2x squared divided by 2 plus x. Now, what integration is this? Let's think about that. There is an x squared in the denominator, and this resembles the tan inverse integration that you've done. So it was, if you have a square plus b square x squared dx, it integrates to 1 over ab tan inverse of bx over a plus c. Okay, that's the integration that I'm appealing to right now. I get x squared plus x plus 6 times a is 2. Okay, 4 a squared is 4, so a is 2 and 1 is 1. My bad, b is 2 and a is 1. So I'm going to get 1 over 2 tan inverse of 2x over 1, which is 2x, and I'm going to integrate and I'm going to put limits 0 and half. Remember that your calculator must be in radians when you put in the limits. So this is going to be 0.5 squared plus 0.5 plus 6 plus 0.5 times tan inverse of 2 times 0.5. That's the upper limit. Let's move that down so that I can write the lower limit as well. 0 plus 0 plus 6 plus, okay, that wasn't 6 times, that was 6 times, my bad. 6 times. Because 6 is outside, it's 6 times. Okay? Okay. Should write 3 here. Write 3 here as well. So I get 0.25 plus 0.5 plus 3 times tan inverse, so 3 pi over 4 and minus 0 the entire thing. So 0.75 is 3 over 4 plus 3 pi over 4. Let's check if that is the right answer to this question. Yes, that is indeed the right answer. Moving on to the next one, I have question number 11 from the same paper again. The diagram shows a curve y equals to this and its maximum point m. Find the x coordinate of m, giving your answer. So u is sine x, v is cos 2x, so u dash is cos x, v dash is minus 2 sine 2x. U dash v plus v dash u. And then equals to 0. Okay. So then I can do sine x, sine 2x over cos x, cos 2x equals to 1 over 2. So that gives me tan x, tan 2x equals to 1 over 2. And then I can go on and say that this gives me tan x, 2 tan x over 1 minus tan square x equals to half. 2 tan square x equals to 1, 1 minus tan square x. So 1 over 2. Cross multiplying gives me, I don't know if I have a different page, but I'll have to manage here only. So I'm going to be a little wise and sort of move that here. So that I have that space. So 2 tan square x, 4 tan square x cross multiplying equals to 1 minus tan square x. So 5 tan square x equals to 1, and tan square x gives me 1 over 5. Tan x is either plus minus root of 1 over 5. Now since I want the answer in the first quadrant only, I can simply say that I can just calculate alpha and I should get my answer. I'm just going to check if I've done this correctly. This should be there. Yep, I've done this correctly so far. Let's put a calculator in radians. It's already in radians. Tan inverse of 1 divided by root 5, and I get 0.421. So x equals to 0.421. Then the second part to the question says, using the substitution u equals to cos x, find the area of the shaded region enclosed by the curve and the x-axis in the first quadrant, giving your answer in a simplified exact form. Okay. So I have to integrate sine x and cos 2x. What limits do I have? I have this. I have to find this limit first. How do I find this limit? I'm going to say that y equals to sine x and cos 2x equals to 0. So either this equals to 0 or that equals to 0. Sine x is 0 on 0 and then pi and then 2 pi and so on. So x is either 0, pi and 2 pi. None of that sounds reasonable. Cos is 0 on pi over 2 and then 3 pi over 2. So I think I should get my answer. X should be pi over 4 or 3 pi over 4. I'm going to go with the first answer that I get. So I'm going to say that this is from 0 to pi over 4. There's a dx here. Then u equals to cos x, so I don't see an immediate substitution. So I'm going to differentiate my substitution first and say that this is du over dx cos x. So I can replace du with sin x, sorry, sin x minus sin x, in fact. So minus sin x and dx. Okay, so I can write sin x cos 2x du over minus sin x. So the minus comes outside and I have cos 2x here. What can I, and du here. So I can write 2 cos square x minus 1 as a minus outside. So I get 2u square minus 1 du. I can take the minus inside and say 1 minus 2u square to simplify some calculations. I will also have to change the limits. Cos of 0 is 1 and cos of pi over 4 is 1 over root 2. Okay, so 1 to 1 over root 2. So u minus 2u cube over 3, 1 and 1 over root 2. So 1 over root 2, or let's write that as root 2 over 2 so that we don't get confused. Root 2 over 2. minus 2 root 2 over 2 cubed over 3. That's the upper limit. And that's the lower limit. You can see that the lower limit is larger, but that's fine. Okay. Simplified exact form. So that's root 2 over 2. What's root 2 over 2 cubed? It's root 2 over 4 into 2 divided by 3. So that gives me root 2 over 6 minus 1 plus 2 over 3. So plus root 2 over 2 minus 1 plus 2 over 3. I'm getting minus 1 plus root 2 over 3. And that in decimals, I don't want to get decimals. So let's see if I got the correct answer. Root 2 minus 1 over 3. Yep, that's the correct answer. Okay, continuing with the questions. This is a polynomial 2x cubed. Polynomial 2x cubed minus x squared plus a, where the constant is denoted by p of x. It is given that 2x plus 3 is a factor. So x equals to minus 3 over 2. And let's plug that in here. A should equal 0. Why? Because the remainder is equals to 0. So 2 times minus 1.5 cubed minus 1.5. Okay, that gives me minus 21 over 4. I'm just wondering if that is the correct. Oh, there should be a square here. Okay, so that's giving me minus 9 plus a equals to 0, a equals to 9. Okay, let's just quickly open up the marking schemes to know what this is. November 2232. Okay, this is the correct answer. When a has this value, solve the inequality p of x is less than 0. So remember that you cannot solve inequalities, like you can't solve equations without factorizing them first. So that is what I'm going to try to do. I'm going to say that 2x cubed minus x squared plus minus 9, the minus sign, no, plus sign, is less than 0. So I need to factorize this first. I'm going to take it and do a comparison. Okay, I have 2x plus 3. I'm going to write bx squared plus cx plus d. Why? Because I want to create a cubic situation. I get 2bx cubed plus 2cx squared plus 2dx plus 3bx squared plus 3cx plus 3d. Okay, so 2b should equal 2, so b should equal 1, and 3d should equal 9, so d should equal 3, and 2c plus 3b should equal minus 1. C equals to minus 2. So I'm getting 2x plus 3 and x squared minus 2x plus 3. Okay, then taking out the roots, 2x plus 3 equals to 0, or x squared minus 2x plus 3 equals to 0. Let's check if we have the factor right. I just want to be sure before I solve it any further. Yes, this is the correct factor. So let's take out the roots. Can I factorize this? This is not factorizable. Let's check for the roots. On my calculator, if I solve this, I'll know if it has roots. It has no real roots. Okay, so there's just one root, x equals to minus 3 over 2. Then whenever you're trying to solve an inequality, there are multiple ways of doing it. What you can do is you can now make a small sketch and say that this curve will start from the bottom. Why? Because the coefficient of x cube is positive, it's going to turn somewhere from up there and go like that. Okay, it's going to have two turning points. Where is this greater than, where is this less than 0? It's less than 0 in this region. So I'm going to say that the answer to the inequality is x is less than minus 3 over 2. Had there been other routes, I would have found the shaded area and so on and come up with the final answer. Okay, that was to show you how to solve cubic inequalities. It wasn't a difficult question. Okay, then this question has a difficult prompt at the start, which is why I'm solving it. This is also November 2232. Okay, the variables x and y satisfy the differential equation this. It is given that x equals to 2 and theta equals to pi over 4. Show that d over d theta of cot square theta. Now, I'm not asking you to do a differential equation right now. I'm just asking you to differentiate this. Basically, differentiate cot square theta. How do you, if y equals to cot square theta, let's call that dy over d theta. Okay. Now, I would call that tan theta power minus 2, just to make sure that my differentiation is convenient. Okay, I'm going to say that dy over d theta is minus 2, just a moment. Okay, so what I'm going to do is I'm going to show you something directly. Dy over d theta. Okay, so 2 bracket cot theta power 2 minus 1, which is 1. Okay, and then the differential of cot theta. Now remember that these differentials that are there in the formula sheet are always useful. So there is one for cot theta, which is minus cos x square x. Okay, so and in the recent past papers, it's turned out that you should know these. So minus cos x square theta should be my differential. Okay, that gives me 2 cot theta into minus 1 over sine square theta, and that should solve the problem. Minus 2 cot theta over sine square theta, which is why this is just 1 mark. You may assume that the derivative of cot theta with respect to this is this. It's already written here as well, so I should go ahead and do that. Okay, solve the differential equation to find the value of x when theta equals to pi over 6. So I have this differential equation here. Let's try that first and then try to integrate that. Now, I can expect that this differential equation will be a lengthy process. I think I have the other page as well, but I'm going to still start writing in a way that is easier for me to do. Okay. So I have x dx and tan square theta minus 2 cot theta over sine square theta, and I have d theta here. Integrating both sides, I think that's the only x that I have. Yeah. Okay. So this becomes x square over 2 equals to, now to integrate this, I'll have to first separate this tan square theta over sine square theta minus 2 cot theta over sine square theta d theta. Now if I simplify sine square tan square theta into sine square theta over cos square theta, and then it's divided by sine square, so this cancels out, and I have minus 2 cot theta d theta over sine square theta d theta. Okay, then I have 1 over cos square is sec square theta, and can I put a separate integral sign here and say that this is what we differentiated up top? Okay, this is the same differential that you got. So if I were to integrate this, I would get cot square theta. So sec square theta integrates to tan theta, and that integrates to cot square theta plus c. So x square over 2. And then I have to find the values of c and find the value of x when theta equals to pi over 6. So 2 and pi over 4 first. So 2 square over 2 equals to tan pi over 4 plus 1 over tan square pi over 4 plus c. Tan pi over 4 is 1. Tan square will also be 1. And this is 2. So c comes out as 0. Okay, so I have x squared over 2 equals to tan theta plus cot square theta plus 0. Okay, and what do I want to find? I want to find the value of x when theta equals to pi over 6. Tan pi over 6 plus 1 over tan pi over 6 squared. Okay. Okay, tan pi over 6 is root 3 over 3 plus 1 divided by answer squared is 3. Okay, and x squared over 2. Is it the exact value? And find the value of x. So it's just the value of x. Okay, so plus root 3 over 3 into 2 and root of answer. So x comes out as 2.67. And that is the correct answer. Okay. Moving on to the next question now that I have for you. This is again the same paper, November 2232. Let's start solving this. I think I've kept this here just to show you the integration in the latter part. Let's quickly do the partial fractions. I think everybody should be comfortable with this. Okay, I have 1 plus x and 2 plus x square. So my partial fractions will be a over 1 plus x plus bx plus c over 2 plus x squared. Okay, a into 2 plus x squared plus 1 plus x into bx plus c. And I have 4 minus x plus x squared here. 4 minus x plus x squared. And then you try to make the brackets 0. Okay, so x equals to minus 1. So 4 minus 1 plus minus 1 squared. A2 plus 1 plus 0. Okay, so 4 plus 1, 5, 5 plus 1, 6. 3a equals to 6, a equals to 2. Now for the other bx plus c, since I don't have no other bracket, I can take any value of x. So I'm going to first go with 0 and then see how it works out. So I'm taking x equals to 0 now. 4, 2, 1, and c. 4 equals to 2 times 2, so c equals to 0. Okay, then I can take any other value for x. I'm going to take x equals to 1. 3a plus 4b equals to 4. 3 times 2. I'm a little unsure if this is the right number that I'm going to get. I'm getting PS minus half. Let's just check if our calculations are correct. Now there is something wrong. What have I done wrong here? 3a to okay, that should be 1b, right? Yep, 2b. So b should be minus 1. Okay. Okay. So I have my partial fractions. I have 2 over 1 plus x plus minus x over 2 plus x squared. Okay, that is what I have to integrate now. Okay, so this is simple integration 2 ln 1 plus x divided by 1. Okay, and I have the limits 0 to 4. And this is integration by recognition. Okay, so I'm going to move the minus outside and say that how do I recognize this? the differential of the denominator, which is 0 plus 2x, and 2x can be visible in the numerator. If I just modify this a little bit, I add it to the numerator and a half outside to balance it. So this becomes half ln of the denominator. Okay, and then I have the limits 0 to 4. So 2 ln 5 minus half ln half ln 18. Okay, 4 square 16. Okay, and then I have minus 2 ln 0 minus half ln 2 ln 5 minus ln half ln 18 ln 0 ln 1, sorry, not ln 0, ln 1. ln 1 is 0, so that's 0 plus half ln 2. Okay, so ln 5 is the same exact value as a single logarithm. So I'm just going to go ahead with single logarithm. I'm going to say that this is 18 power half and this is 2 power half. So that gives me ln 25 into root 2 over root 18. Okay, root 2 over root 18 should give you a number 1 over 3. So ln 25 over 3 should be my final answer. Let's quickly check from our calculations. Yes. Okay, that is the other question. Let's move on to the next one now. This one is June 2331. Okay, and this is a differential equation. It says where x and y satisfy the differential equation. This solve the differential equation. Okay, so sine square 3y dy for tan 2x over cos 2x dx. Okay. Sine square 3y. Now this is a double angle thing that you need to know. For example, for reminders, I'm going to use this version of the double angle identity. I'm going to say that this used to turn out as minus 2 sine square x. Okay, if this is 3y, then this will be 6y. Okay, and if I make this the subject, it becomes half minus half cos 6y. Okay, integration of that. Now for tan 2x over cos 2x, if I change tan 2x to sine 2x over cos 2x, it's going to make it very messy. I'm going to have cos squared in the denominator. Uh, and Okay, so there are multiple ways of doing this. One is what the examiner expects you to know is that sec 1 over cos 2x is sec 2x, so you get sec 2x tan x. Now, this identity that's there in the formula sheet, but you never sort of go ahead and um use it, you've probably never used it, is this, that the differential of sec x is sec x tan x. So this is what I've created here. Instead of sec x, I have sec 2x. So when I integrate this, I should get 4 sec 2x divided by 2. Okay, plus c on this side. I'm going to say that, and this integrates to half y minus half sine 6y divided by 6. Okay, that should be my integral. Let's quickly check if that is the correct integral that I need to have. I'm just trying to make sure. I'm going to also tell you another way of thinking about this question as well, something that's also come up in the recent past papers, so something that you should know. uh, June 23, I don't have the marking scheme. Okay, yes, that is the correct answer. Now, there are two other ways of handling this question. One is through, now, imagine that you didn't know what the integral of this was. So what would you do on the exam? There are two things that come up. One is that you could go ahead and start doing integration by parts. At some point, you will see that the expression that you have on the right-hand side becomes equal to the expression on the left-hand side. That's a very challenging thing to do on the exam. So what I suggest instead is that what you do is you try to think about the fact that if I were to simplify this and bring it into this form, that's tan 2x was to become um, sine 2x over cos 2x, this should give you a square. Now, this resembles an integration by recognition, although it's not technically an integration by recognition. Why? Because the differential of the numerator denominator is not visible in the denominator. Now, although the syllabus says that you only need to be able to use substitution when given, this is a question where you could, and there's another question like that as well, where you can use substitution even when it's not given. What I'm thinking about is that substitution is technically taking you in the reverse order. So if you notice, you can see that the differential of cos 2x is there in the numerator. Okay, so what if I were to take a substitution myself and say that u equals to cos 2x? Okay, du over dx would then be minus 2 sine 2x, and du would be du over minus 2 sine 2x would be dx. Okay, so what do I get then? I get, if I do the substitution, I get u square here and du over minus 2 sine 2x here. Okay, this would cancel out. I'd get minus 2 u power minus 2, and integral of that would be minus 2 plus 1 divided by minus 1. So I'd get 2 over u plus c. Now what was u? Remember that it was cos 2x plus c. So that technically equals sec 2x, 2 sec 2x. Okay, so that's the same integration that you get. So you could have done it with integration by substitution, although the substitution is not given to you. That's something that you need to be aware of. Otherwise, you could use whatever is given in the formula sheet. That is what the examiner suggested in the examiner report as well. Okay, it is given that y equals to 0 and x equals to pi over 6. So half into 0 minus 1 over 12 sine 6 into 0 equals to 2 sec pi over 3 plus c. 0 sec pi over 3, 1 over cos. It gives me 2. So 2 into 2 gives me 4. So c equals to minus 4. So I have half y minus sine 6y over 12 equals to 2 sec 2x minus 4. Then I want to obtain the value for x when y equals to pi over 6. Y equals to pi over 6. That's weird. Okay. So that gives me pi over 12 sine pi over 12 4 sec 2 sec 2x minus 4. So what's sine pi? Sine pi is 0. So pi over 12 plus 4 divided by 4 equals to 1 over cos 2x. So cos 2x would be pi divided by 12 plus 4 divided by 4 and 1 divided by answer 0.9386. I want it to be in the first quadrant. Okay, x is between 0 and pi over 4. That's a very narrow range, by basically 90 first quadrant. So alpha is equals to cos inverse of 0.9386. Point 3523. So 2x equals to 0.3523 divided by 2. 0.176. Okay, long question. Let's see if that is the correct answer that I have from the marking scheme. No, it's 0.541. So let's check what our mistake is. My mistake is very simple. It should have been 2. I don't know why I've written 4. So divide by 2. And that number changes. That's 0.4693. 1.082 and 0.541. Okay, simple writing mistake because it's a long question. Okay, let's take you to the next difficult question then. This is from June 2331 as well, and this is one on complex number. Let's see the polynomial. This is denoted by p of x. Show that this is a factor, so that's simple. So minus 27 plus 45 minus 63 plus 75. No, minus 93. Okay, that's 0. That's shown. Show that this is the root of the equation. This. Okay, so minus 1 plus 2 root 6 I cubed plus 5 times minus 1 plus 2 root 6 I squared plus 31 times minus 1 plus 2 root 6 I and then plus 75. Okay, so I'm just going to square first. Why? Because once I have the square, it's easy to cube it. Okay, so I'm going to say a square minus 2ab plus b square. So what's the root of what's the square of 2 root 6? That's 24. So I get 24i square. So plus 5 times 1 minus 4 root 6i minus 24 plus 5 times minus 4 root 6i minus 23. Okay, so I have minus 1 plus 2 root 6i into minus 4 root 6 I plus minus 23. So I've broken up a cube into power 1 and a square. Then I'm going to multiply minus 1 times 4 root 6i. So 4 root 6i. And then plus 23 plus what's 2 root 6 into 4 root 6. Let's do that on our calculator so that we don't mess up. It's 48. So minus 48i squared minus 23 into 2 is 46 root 6i. Okay, this gives me minus 31 plus 62 root 6i plus 75. 75 minus 31 is 44, so plus 44 plus 62 root 6i. So I have 23 plus 48 from here. So I have 71 minus 40 root 6i. 71 minus 40 root 6i minus 20 root 6i. Okay, this is 42, not 40. 42. Okay, 5 into 23 is 115. So complicated numbers here, but I see that my answer is emerging because this cancels out with both of these, and 71 plus 44 is 115, so 115 minus 115 gives me 0. Okay, continuing with this question, hence find the complex number z with the roots of pz squared. Okay, so I for this cubic equation you already have three factors. You have a factor x plus 3. Okay, so let's if I were to solve this equation, z cube plus 5z square plus 31z plus 75. Okay, let's say I was just solving p of z equals to 0. So I know that there would be three solutions: z equals to minus 3, z equals to um, minus 1 plus 2 root 6i, and z equals to minus 1 minus 2 root 6i. Now, when I replace z with z square, these roots automatically become roots of this. Okay, then if I want to find z, then I take a root on both sides and say that z is plus minus root 3i. Okay, so that's one set of roots. Then if I want to root this, I know that the root of a complex number cannot be obtained directly. I will have to do this: a plus bi whole square equals to minus 1 plus 2 root 6i. Okay, and in order to solve for z, I'm going to say that a square plus 2abi plus b square I square should b square I square should equal minus 1 plus 2 root 6i. So a square minus b square plus 2abi equals to minus 1 plus 2 root 6i. So a square minus b square should equal minus 1, and 2abi should equal 2 root 6i. 2 and 2 cancel out. I and I also cancel out. AB equals to root of 6. Okay, and a square minus b square equals to that. So b equals to root 6 over a. So I'm going to say do root 6 over a whole square equals to minus 1. I get a square minus 6 over a square equals to minus 1. This turns into a disguised quadratic equation, and I can either factorize this to solve for a square, or I can use my quadratic formula. The answers that I'm going to get out of the quadratic, I'm just going to factorize this for you so that you can see. I'm just going to say that a power 4 minus 3a square plus 2a square minus 6 equals to 0. So a square minus 3 plus 2a square minus 3 equals to 0. So a square minus 3 and a square plus 2 equals to 0. So a square could equal 3, a square plus 2 could equal 0, a square equals to minus 2. Now I've kept a as the real part, so I want real answers, so I'm going to discard this. Maybe it's going to turn up in the next one. So a could be plus minus root 3i, root 3i, yeah, okay, plus minus root 3i. So if a is root 3i, then b should be root 6 divided by root 3. Sorry, this won't have an I, my bad. Okay, plus minus root 3. B equals to root 2. So my value for z will be root 3 plus root 2. And when a is negative, root 3 minus root 2i. Okay, I is going to come up here. Then for the other complex root that I had, I'm going to do the exact same thing. I'm going to say that, let's call that c plus di whole square equals to minus 1 minus 2 root 6i. Okay, c square minus d square plus 2c di. I'm going to use the exact same idea here as well, and then try to solve. So c square minus d square equals to minus 1. 2cd equals to minus 2 root 6. cd equals to minus root 6. Okay, c square minus root 6 over c square equals to minus 1. D equals to minus root 6 over c. Okay, just putting that out there. So this becomes an exact similar version of what I had on the other side. So again, c is going to be either root 3 or c is going to be minus root 3. But in this case, d is going to be minus root 2 and plus root 2 in this case. You can plug in and find out. So z is going to have minus root 3 plus root 2i and my plus root 3 and minus root 2i and minus root 2i and minus root 3 plus root 2i. Okay, so the six answers that I have are this. Those are from above. Okay, these were the ones that I found earlier. Then I found the other two. So two answers, and two answers. Let's check if I've done all of this correctly. 2 plus root 3 minus 2. Okay, all my answers are reversed because of this stupid sign mistake that I made here. So let's correct all of that. So this one is going to get discarded. I will have to change all the signs now. Okay, so a is going to be minus 3 and a square is going to be 2. So a equals to plus minus root 2. That's a very stupid mistake, but I've made it, so I have to correct it. Then I'm going to get root 3. So this will change to root 2. This will change to root 3, root 2, and root 3. And then here as well, root 2, root 3. Okay, so all my answers were reversed because I took the number incorrectly. Okay, yeah, that I think should solve the problem. And let's see if we get the correct answers. Root 2 plus root 3. So I get no answer marks technically. I would just get 5 out of 7 because I messed up the numbers there. Okay, so minus root 3 plus root 3, root 2 plus root 3, root minus root 2, root 2 minus root 3i, and yeah, all of that is complete now. So tough question. Moving on to the next one. This is from June 2232, and this is a vectors question that I'm now solving for you. Okay, the lines L and M have vector equations this. Given that L and M intersect, show that 2b minus a equals to 4. So let's go ahead and do our intersection. Minus 1, 3, 4 plus lambda times 2 minus 1 minus 1 and 5, 4, 3 plus mu times a, b, and 1. Okay, so minus 1 plus 2 lambda. Okay, so this should equal 5 plus mu a. 3 minus lambda should equal 4 plus mu b. And 4 minus lambda should equal 3 plus mu. Okay, taking a substitution for mu from here. And I say that mu is 1 minus lambda. And I put it here. 1 minus lambda b. I get 3 minus lambda equals to 4 plus 1, 4 plus b minus lambda b. Let's gather the lambdas on one side. Lambda b minus lambda equals to 3. 4 minus 3 is 1. 1 plus b. Lambda common, b minus 1 equals to 1 plus b. Lambda equals to b plus 1 over b minus 1. Minus 1 plus 2 times b plus 1 over b minus 1 plus equals to 5 times 1 minus lambda, and then lambda is itself b plus 1 over, let's do that in a different, 1 minus lambda a equals to 5 plus a minus lambda a, 5 plus a minus, it's become a little more complicated than I wanted it to be. Let me see if I can simplify that. No, I think that's as complicated as it gets. So lambda is then b plus 1 over b minus 1 times a. Okay, taking a common denominator gives me b minus 1 minus b plus 1 plus 2b plus 2 equals to 5 plus a minus a b plus 1 over b minus 1. 5 b minus 1 plus a b minus 1 minus ab minus a over, I've taken a common denominator now so that I can cancel both sides out. So b plus 3, 5b minus 5 plus ab minus a minus ab minus a. So I need 2b minus a equals to 4. So 3 plus 5, 5b minus b minus 2a. So 4b minus 2a equals to 8. And I proved it. Slightly long, but I don't know if I could have made this shorter. That's the final answer. Given also that L and M are perpendicular. When they are perpendicular, the dot product of their directional vectors should be 0. So 2 minus 1, 2 minus 1 and minus 1 dot a, b, and 1 should equal 0. So 2a minus b minus 1 equals to 0. So 2a minus b equals to 1. B minus 2a should equal, let's just keep that way. 2b minus, so I have two equations now. Okay, I can take a substitution. A is equals to 2b minus 4. So 2b minus 4 minus b equals to 1. 4b minus 8 minus b equals to 1. 3b equals to 9, b equals to 3, a equals to 6 minus 4. So b equals to 3 and a equals to 2. Let's check from our marking scheme. I haven't opened up this marking scheme, so I will have to open this up. This is June 2232. Yes, those are the correct answers. Let's move on to the next one. I have question 10. It says the complex number. I think I missed out on some question earlier. Let me check if I wanted to do another question, which I haven't. Okay, let's do this one. There is something that I want to explain to you here as well. So x squared plus 9x over 3x minus 1, x squared plus 3, a over 3x minus 1 plus bx plus c over x squared plus 3, a times x squared plus 3 plus bx plus c times 3x minus 1 equals to x squared plus 9x. Okay, so when x equals to 1/3, So 1/3 squared plus 9 times 1/3 equals to a into 1/3 squared plus 3 plus 0. So 1 over 9 plus 3 is 3 whole 1 over 9. 1 over 9 plus 3. It's 28 over 9. And a is 1. Okay, for the other values, we start with x squared plus 9x equals to a, x squared plus 3 plus bx plus c, 3x minus 1. I take x as 0. So 0 plus 0 equals to a into 3 plus c into minus 1. So I get 3a equals to minus c, and c equals to 3a, and a is 1, so c is 3. Okay, and then I have x squared plus 9x equals to a, x squared plus 3 again. So I get, let's take x equals to 1 in this case. So 1 plus 9 equals to a into 4 plus b plus c into 2. Okay, 10 for a, 6 divided by 2, b plus 3, b equals to 0. So my partial fractions are 1 over 3x minus 1 plus 0x plus 3 over x squared plus 3. Okay, it's the next part that I really wanted to solve, so I'm going to do that. So ln 3x minus 1 divided by 3, and this is the tan inverse integration. So if you remember from our earlier examples, I have 1 over a square x square plus b square, or rather b square x square plus a square. It used to become 1 over ab tan inverse of bx over a. So I can get 3, 1 over root 3 tan inverse of x over root 3. And then the limits I have are 1 to 3. So ln 9 minus 1 divided by 3 plus 3 over root 3 tan inverse of 3 over root 3 minus ln 2 over 1 over 3 plus 3 over root 3 tan inverse of 1 over root 3. Okay, so ln 8 divided by 3 tan inverse of 3 over root 3 pi over 3 3 over root 3. Okay, and tan inverse of 1 over root 3 pi over 6 pi over 6. Okay, um if I take this 1 over 3 to the power, I get ln 2 minus ln 2 over 3 plus 2 root 3 and I get 2 pi minus pi. So ln2, that's 2/3 ln2 plus pi root 3 over 6. That's from my calculator. I just did 1 divided by 2 root 3. So I get root 3 over 6 and I subtract to get pi. Let's check if that is the correct answer. This is question number 9, I think. It's question number 8. 2 over 3 ln2 plus pi root 3 over 6. Yes, that is the correct answer. Let's move on to the next question that we have here. Okay, we were doing a vectors question that I didn't solve completely. Okay, when a and b have these values, find the position vector of the point of intersection of L and M. So I think that's pretty clear. I can just use these values to find the position vectors. I had mu equals to 1 minus lambda, and I had lambda equals to b plus 1 over b minus 1. So I can get lambda equals to 4 over 2, which is 2. So mu should be 1 minus 2, which is minus 1. So I have lambda equals to 2 and mu equals to minus 1. So I can use that in the first set, minus 1, 3, 4. Minus 1, 3, 4 plus lambda times 2 minus 1 minus 1. Okay, so I get 3, 1, and 2. If that was the correct answer. Yeah, that is the correct answer. Okay, moving on to the next difficult question that I have here. That is again from the same paper. It's question number 10. The complex number this is denoted by u. It is given that u is the root of the equation. Find the value of k. So I think I can just simply put it here and find the value of k. Okay, I will break this up into cubes and squares. And first I will square this. A square minus 2ab plus b square, and that's 7i squared Okay, let's first simplify this and then we're going to open this up. 3 times minus 6 is minus 18 minus 6 root 7i. And minus 6 minus 2 root 7i into minus 1 plus root 7i. So I get 2, 6 minus 6 root 7i plus 2 root 7i minus 14i squared minus all of that. Okay, so 12 minus 12 root 7i plus 4 root 7i minus plus 14 plus 28 minus 18 minus 6 root 7i minus 4 plus 4 root 7i plus k. Okay, so I'm getting minus 8 from here and minus 2. So I must have made a mistake somewhere. Let's quickly try that, figure that out. 6 minus 6 plus 2 root 7. Okay, let's check from the marking scheme if we have done this correctly. This k equals to minus 8. I have 40 and 4 root 7 minus 4 root 7I. There's some problem with the expansion, I think. Let's try. Minus 8 root 7I plus 28 minus 18 minus 6 root 7I. Okay, instead of 14, I have 4 here, so that should mess it up. 14, yeah. That's a silly mistake that I've done. Okay, let's see if that solves the problem. Okay, so minus 8 and minus 6 give me 14, so that cancels out. And 12 plus 28 minus 18 minus 14. So k is 8. Find the other two roots of the equation. Okay, so one root must be the conjugate of this, and for the other root we'll have to do a bit of long division or comparison to find out the other root. Let's do that. Okay, so I get x plus 1 plus root 7i and x plus 1 minus root 7i, and then ax plus b for the third root. Let's first multiply these together. I get x squared plus x minus x root 7i plus x plus 1 plus minus root 7i plus x root 7i plus root 7i minus 7i squared, ax plus b. X squared plus 2x plus 8, ax plus b. Ax cubed plus bx squared plus 2ax squared plus 2bx plus 8ax plus 8b. So a should equal to b plus 2a should equal 3. So b plus 4 equals to 3, b equals to minus 1. So I have a and b, so that's 2x minus 1, and that should be the third root. Equals to 0, 2x equals to 1, and x equals to half. If that is the correct answer, yes, that is indeed the correct answer. Okay. Then the part C for this, on an Argand diagram, sketch the locus of points representing the complex numbers this and that. So satisfying this. So I need to draw a circle at U. U is basically minus 1 plus root 7i, so minus 1 on the real axis, and root 7 is basically okay. So drawing this, I have I don't know why it's showing up as a thick line. Let me just draw this. Okay, and then marking my minus 1, minus 2, minus 3, and minus 1, minus 2, and minus 3. Okay, then turning that around and saying that I need to now draw a vertical line. Root 7 is basically 2.65 in decimals. So I will have to draw 2 points. Will have to at some point mark 2.65. So 1, 2, and 3. Okay. So 2.65. Let's just try to mark 2.65 here. So minus 1 plus 2.65. Okay, drawing this, I have this as the center, and then I need to have radii of 2 centimeters. So what I'm going to do is I am also going to mark some points. On the exam, you will probably have uh, a compass to draw this. So since I don't have a compass, I'm going to just try to do this manually. Okay, so this is what my shape will look like. This is 2 centimeters and it has u as the center. I'm going to mark that so that there are no confusions. Minus 1 and root 7 is the point that I've marked. Okay, determine the greatest value of arguments of z for the for points on this locus, giving your answer in radians. So greatest argument is always the a tangent line. Since z is any point on the circle, okay, since this is equals to 2, z is any point on the circle, I'm going to say that it's tangent here. Remember that the center has an interesting role to play whenever the greatest or least arguments are asked. So I am trying to find this angle here. This is going to be 90 degrees. What I'm trying to find is the entire argument. Okay, but in order to do that, I'm going to split up the circle and say that first I have this portion and I'll call that theta. This distance is 2, and I can find the hypotenuse. I can say that the hypotenuse is basically minus 1 squared plus root 7 squared. So I get root of 8. So that's root of 8. I can say that I can then find out what have I labeled this as? I've labeled this as theta. So theta equals to sine inverse of 2 over root 8. Okay, sine inverse of 2 gives me pi over 4. Okay, then for the center itself, what I can do is I can find a certain angle or the argument of the center, argument of u, and I can say that that's tan inverse of first I'm going to find out its basic angle. So basic angle is tan inverse of root 7. Okay, tan inverse of root 7 over 1 basically. So root 7 gives me 1.209. I'm going to say that the greatest, and the argument then becomes, since it's in the second quadrant, it becomes pi over pi minus 1.209. Okay, so greatest argument is therefore pi over 4 plus pi minus 1.209. 2.717. Let's check. 2.72, is that the correct answer? It's a long question. Yes, that is indeed the correct answer. I hope that was productive for you. What I've done is I found out this angle separately. Then I've tried to find out the argument of this, which would be basically the angle from here to here. And then I've added the two angles together to find out the greatest argument. Thank you for watching. I will be back with another set of difficult questions for P3 in the next video.